First, heat is a form of energy that flows between a body and its surrounding medium by virtue of temperature difference between them. The degree of hotness of the body is quantitatively represented by temperature. Second, a temperature measuring device, thermometer, makes use of some measurable property called thermometric property that changes with temperature. Different thermometers led to different temperature scales. To construct a temperature scale, two fixed points are chosen and assigned some arbitrary values of temperature. The two numbers fix the origin of the scale and the size of its unit. Third, the Celsius temperature Tc and the Fahrenheit temperature Tf are related by Tf equals to 9 by 5 Tc plus 32. Fourth, the ideal gas equation connecting pressure P, volume V and absolute temperature T is PV equals to mu RT, where mu is the number of moles and R is the universal gas constant. Fifth, in the absolute temperature scale, the zero of the scale is the absolute zero of temperature. The temperature where every substance in nature has the least possible molecular activity. The Kelvin absolute temperature scale T has the same unit size as the Celsius scale Tc but differs in the origin. Tc equals to T minus 273.15. Sixth, the coefficient of linear expansion alpha L and volume expansion alpha V are defined by the relations delta L by L equals to alpha L delta T, delta V by V equals to alpha V delta T, where delta L and delta V denote the change in the length L and volume V for a change of temperature, delta T. The relation between them is alpha V equals to 3 alpha L. Seventh, the specific heat capacity of a substance is defined by S equals to 1 by m delta Q by delta T, where m is the mass of the substance and delta Q is the heat required to change its temperature by delta T. The molar specific heat capacity of a substance is defined by C equals to 1 by mu delta Q by delta T, where mu is the number of moles of the substance. 8. The latent heat of fusion LF is the heat per unit mass required to change a substance from solid into liquid at the same temperature and pressure. The latent heat of vaporization LV is the heat per unit mass required to change a substance from liquid to the vapor state without change in the temperature and pressure. 9th, the three modes of heat transfer are conduction, convection, and radiation. 10th, in conduction, heat is transferred between neighboring parts of a body through molecular collisions without any flow of matter. For a bar of length L and uniform cross-section A with its end maintained at temperatures Tc and Td, the rate of flow of heat H is H equals to KATC minus Td by L, where K is the thermal conductivity of the material of the bar. 11th, Newton's law of cooling says that the rate of cooling of a body is proportional to the excess temperatures of the body over the surroundings. dQ by dt equals to minus KT2 minus T1, where T1 is the temperature of the surrounding medium and T2 is the temperature of the body.